Now I have a piecewise graph and I want to write a function for it. Notice it has 3 pieces, so I'm going to end up writing a piecewise function that has 3 lines in it, 3 different function rules for 3 different sections of the domain. So the first thing let's do is look at the sections of the domain that we need. Okay, so I'm going to draw some little dotted lines just separating the sections of this graph. And we're going to notice where it's separated. So what I want you to notice here, in section 1, right here, notice that the x right here is 1. It's halfway between the 0 and 2, so x is 1 right here. So this goes all the way then to negative infinity. So one section of my graph is everything where x is less than 1. Okay, and notice there's an open circle right here, so I can't say less than or equal to 1. It's just everything less than 1. So on this section of the graph, every x value on this section of the graph is less than 1. Now here we have 2 closed circles, so we're going to have an equal to. So here, and notice I've labeled this point too. So there's negative 1 is the biggest x value on this section of the graph. Here my x values are between negative 1 and 2. So for this section of the graph, I have negative 1 is less than or equal to x is less than or equal to 2 for that section, that middle section of the graph. And for the right-hand section, notice that x is bigger than 2. So here x is greater than 2. So when I do my piecewise function, I'll just call it f of x, I'm going to have 3 lines. And in the first line, so I'm going to have 3 different functions. I'm going to leave a little space for it. In the first section, the portion of the domain I'm using is x less than, actually that should say less than negative 1, not positive 1. So let me do that again. Some of you have probably been noticing that already and probably going, half point, I need a half point for that. So here we go, negative 1. X is less than negative 1. X is less than negative 1. In the second section, we have negative 1 is less than or equal to x is less than or equal to 2. And in the third section, we have x greater than 2. Now, interestingly enough, we don't use interval notation to state the different sections of the domain in a piecewise function. I've never seen interval notation used. I'm not saying it never has been, but I've just never seen it. I'm going to scoot these down just a wee bit so we can spread out a little. Okay, so section number 1, I'm going to number, this is number 1. Then we'll do number 2 is this one, and then I'm going to use a different color for number 3. So here's section number 2, and then maybe I'll put them all down at the bottom. So here's section number 2, and then section number 3 I'm going to use a different color. So here's section number, oops, let's try this again. Where's my color? Section number 3. Okay, so section number 3. All right, so going back to my red. Where's my red? Oh, it's not showing up. That's very odd. Red pen. So looking at this here, I notice I've got this graph. It's a line, and I've got 2 points on the line, negative 2, 0, and negative 1, 2. So let's just look at number 1. It is a line, and the way you write the equation of a line, if you have forgotten, is as you go from left to right from one point to another, how far do you go in the y direction, and how far do you go in the x direction? We're going down 2, so this is negative 2, and then we're going over 1. So slope, which is abbreviated, it's symbolized with an m in y equals mx plus b, is the change in y divided by the change in x as you go from one point to another, left to right. So as we go, we're going to go negative 2 in the y direction, 1 in the x direction, so the slope here is negative 2. Another way to figure that out is to do the slope is y2 minus y1 over x2 minus x1. I personally find it's easier just to count off the graph, but if you want to do that. So I can subtract the two x coordinates. So negative 2 minus 0 over negative 1 minus a negative 2. So this gives me negative 2 over 1. So because minus a negative 2 gives me plus 2, so same thing, negative 2. Let's go back to red here. Okay, negative 2. All right, so the slope is negative 2. Now, how do you find the rest of the equation? So I have y equals mx plus b. Slope is m. Slope is the number that's multiplied times the x coordinate. It tells me how much I change every time x goes up 1, y goes down 2. So if x is 1, it's 1 times negative 2. If x is 2, it's 2 times negative 2. Now I need to figure out what this value is in order to get my equation. So this is, I need to know this number here. So what I'm going to do is I'm going to pick an x and a y to put in along with my slope to figure out what b is. So all I need to know is one of the points. So one of the points, I have a point, two different points I could use. One point is negative 2, 0. The other point is negative 1, negative 2. Negative 2, 0 is probably the easier of the 2 points, so I'm going to use that. It doesn't matter, but 0 is nice to work with. So this is my x and my y that are going to go in the equation. So y is 0 when x is negative 2. So the slope is negative 2, x is negative 2, so that goes in here. This is the slope plus b. So 0 is equal to negative 2 times negative 2, 4 plus b. So that means negative 4 equals b. So my equation now has a slope of negative 2 and a y-intercept b of negative 4. So y equals negative 2x minus 4. That's what's going to go in the first line. Y equals negative 2x minus 4. Notice if x is 0, y would be negative 4, and that makes sense. If I extend the line down, that looks perfectly reasonable right here. Okay, now number 2. Number 2 is this section right here. All right, this little section right here. I'm going to, as I go from left to right, I go up 1 in the x direction and the y direction and over 1, 2, 3. So slope is the change in y over the change in x is positive 1 over positive 3. Okay, positive 1, positive 3. So there's the slope. I could also find that by subtracting y2 minus y1 over x2 minus x1, but this is easier. Okay. Now I need to find the y-intercept, so I'm going to use y equals mx plus b. The slope is m. I need to put in a point for x and y. I've got two different points, negative 1, negative 3, and 2, negative 2. So it doesn't really matter which one you use. Let's just use 2, negative 2, because one number is positive, so that's always helpful. So I'm going to use this point, 2, negative 2. So this is my x and my y that are going to go into the equation. So substituting negative 2 for y, I get negative 2 is equal to the slope 1/3 times x plus b. Oh yes, you're going to have to work with fractions a little bit here. So I have negative 2 equals 2/3 plus b. So I'm going to have to subtract 2/3 from both sides. Negative 2 minus 2/3 is equal to b. Now I don't want to have negative 2 and 2/3 in my equation. I need to have an improper fraction. So negative 2 is the same as negative 6/3. Negative 6 divided by 3 is negative 2. So negative 6/3 is the same as negative 2 minus 2/3 equals b. So negative 8/3 equals b. You may be running out of room and have to write this differently than I am, but I have a little extra room down here. So there's my slope, 1/3. Y-intercept is negative 8/3. So my equation is y is equal to 1/3 x minus 8/3. Remember that there has to be an x and y in the equation to generate the points on the graph. Let's double check to see if negative 8/3 looks reasonable for us, the y-intercept. So here's negative 1, negative 2, negative 3. Negative 3 would be negative 9/3, so this looks very reasonable as negative 8/3. That would be negative 2 1/3. So that looks really reasonable. So there's my second piece. Y equals 1/3 x minus 8/3. Third piece, pretty easy. What is this equation? This is a constant graph. This is just y is equal to whatever this number is. This number is 1. Y is equal to 1. So my third graph, number 3, let me go to my little green here, is y equals 1, or in this case f of x equals 1. So all I do is put 1 here. So when x is greater than 2, y equals 1. Okay, that makes sense. Every place where x is equal to 2, greater than 2, y is equal to 1. So here is your piecewise function. Okay, obviously not these three numbers. I put those to key you to the work, but so I probably ought to redraw that box here. So let me scoot this one over here. Let's scoot these over. Okay, so here is what the piecewise function looks like. Okay, and now you can write the equation of a piecewise function. Now this is pretty challenging, I agree. So thinking backwards, but hopefully this is helpful.